What would it be like to experience the 4.6 billion year history of Earth's evolution in one go? About 4.6 billion years ago, the solar system was merely a giant swirling nebula composed of hot gases and interstellar dust. During this time, the sun officially ignited. Earth was nothing more than a massive rock hurtling through the orbit of the primordial solar system. The environment was unimaginably violent. Countless smaller rocks, pulled by gravity, continuously slammed into the young planet, causing its size to grow rapidly and eventually forming the proto-Earth. By 4.5 billion years ago, Earth had become a glowing sphere of molten rock, as hot as hell itself. At this point, the planet was still incredibly young, not even 100 million years old. From the perspective of a planet, it was still in its infancy. Earth's thin atmosphere consisted mainly of hydrogen and helium, but because Earth had not yet formed a magnetic field, most of these gases were stripped away by powerful solar winds. The young world had almost no protection from the sun's deadly cosmic radiation. The entire planet resembled a cosmic purgatory. Its surface was constantly bombarded by asteroids and meteorites, increasing Earth's mass through a process known as accretion. It was during this chaotic era that a protoplanet collided with Earth, an impact so catastrophic that it eventually gave birth to our moon. In a world that looked like the end of everything, who could have imagined what Earth would become 4.5 billion years later? And yet, hidden within this destruction were the seeds of transformation. The asteroids that crashed into Earth carried one extraordinary ingredient that would shape the future of the planet: water. As Earth slowly began to cool, heavier elements sank toward the core, while lighter compounds, including water, rose toward the surface. Violent volcanic eruptions filled the atmosphere with carbon dioxide, argon, water vapor, and countless other gases. Over millions of years, water vapor condensed and fell as rain. Oceans began to form. A thicker and more stable atmosphere slowly emerged. After nearly 2 billion years of turbulence, Earth gradually stabilized. A solid crust formed across the planet, and a magnetic field finally shielded the world from harmful solar radiation. The atmosphere was now rich in methane and covered in a thick orange haze, resembling the appearance of Saturn's moon, entity, Titan. Titan rossed the surface. If you had stood on Earth during this era, you would have seen a moon of unbelievable size dominating the sky, because it orbited much closer to Earth than it does today. Over the last 2.5 billion years, the moon has slowly drifted away, and even now it continues to move farther at a rate of 3.8 centimeters per year. Although Earth now looks slightly more familiar, by modern standards, it was still an alien world. Then, something extraordinary appeared. Tiny microorganisms known as cyanobacteria began to spread through the oceans. These primitive organisms possessed an astonishing ability: photosynthesis. Using sunlight, they produced oxygen and released it into the atmosphere in massive quantities. This event transformed the planet forever. Earth entered what scientists call the Great Oxidation Event. Oxygen levels surged across the atmosphere, reshaping the chemistry of the entire world. With almost no competition, cyanobacteria flourished and dominated the planet. For millions of years, they became the undisputed rulers of Earth. But this dramatic rise in oxygen came with consequences. As greenhouse gases were reduced, global temperatures began to fall. Earth slowly descended into one of the most extreme climate disasters in its history: Snowball Earth. Around 1 billion years ago, nearly the entire planet froze over. From the poles to the equator, oceans and continents became buried beneath colossal sheets of ice. For hundreds of millions of years, Earth remained trapped in a deep freeze. Imagine endless landscapes of white stretching beyond the horizon. Mountains disappeared beneath glaciers. Oceans became silent, frozen wastelands. The entire planet transformed into a giant sphere of ice drifting through space. Yet Earth refused to remain frozen forever. Deep beneath the ice, volcanoes continued to erupt for millions of years, releasing enormous amounts of greenhouse gases such as carbon dioxide into the atmosphere. Because the oceans were frozen solid, there was nothing to absorb these gases. The greenhouse effect intensified until temperatures finally began to rise again. The ice melted. At the same time, the constant movement of tectonic plates tore apart ancient supercontinents and reshaped the surface of the planet. Mountains rose. Oceans shifted. Rivers and seas began forming the foundations of the geography we know today. And somehow, despite this unimaginable brutality, life endured. Cyanobacteria survived beneath the oceans, clinging to existence through one of the harshest periods in Earth's history. Soon, the planet would enter one of the most important chapters of evolution, the Cambrian explosion. Around 500 million years ago, Earth had finally thawed. The stage was set for the rise of complex life. The climate was warmer than today, and life exploded across the oceans in astonishing diversity. Trilobites crawled across the seafloor. Brachiopods resembling clams spread in vast numbers. Primitive fish and complex marine vertebrates filled the ancient seas. Among the most terrifying creatures was entity animal Dunkleosteus, Placoder dunkleosteus long. In the waters alongside it swam creatures like entity animal Tiktaalik, Devonian to Tiktaalik Nies. Meanwhile, on land, enormous forests began covering the planet. This became the golden age of the ferns. Towering plants stretched across warm and humid landscapes, absorbing huge amounts of carbon dioxide and releasing extraordinary quantities of oxygen into the atmosphere. Oxygen levels climbed higher and higher, eventually reaching nearly 35%, far above modern levels. In this oxygen-rich world, insects evolved into gigantic forms unlike anything alive today. Massive dragonflies dominated the skies, while giant arthropods crawled through the forests. But Earth was once again approaching danger. Fire is an oxidation reaction. The more oxygen in the atmosphere, the easier combustion becomes. Forests could ignite with terrifying speed. A single lightning strike or even a small spark could unleash infernos capable of consuming entire ecosystems. Earth had become both a paradise for life and a world constantly standing on the edge of catastrophe.